There is a question. Show that if Px is poly in f over x of degree n is greater than equal to 1 and is irreducible over f, then there is an extension E of f such that the degree E over f is equal to n in which Px has a root. इसका प्रूफ देखते हैं. Let fx be a ring of polynomial over f. Let v is equal to px be the ideal of f over x generated by px since px is irreducible over f. Therefore, v is maximal ideal of fx. Consequently, E is equal to fx by n is field. We have to show that the field there exists satisfy the conclusion, the field E satisfy the conclusion of the theorem. First we shall show that E can be regarded as an extension of f even though E does not contain the element of f in their original form. For this we shall show that the field f can be embedded in the field E. Let psi be the mapping from f into E defined by psi alpha is equal to v plus alpha for all a belongs to f. Now psi is 1 1. Let x comma b belongs to f. We have psi alpha is equal to psi beta implies that v plus alpha is equal to v plus beta. X minus beta belongs to v. X minus beta alpha minus beta is equal to fx px for some fx belongs to capital Fx. So since fx is equal to 0, then this imply x minus beta is equal to 0, which implies that alpha is equal to beta. Therefore psi is 1 1. Also psi alpha plus beta is equal to v plus alpha plus beta, or we can rewrite it as v plus alpha plus v plus beta. So it can be written as psi alpha plus psi beta, and psi alpha beta is written as v plus alpha beta, or we can rewrite v plus alpha bracket v plus beta bracket. So psi alpha psi beta. Thus psi is an isomorphism from f into E. F star is equal to v plus alpha such that alpha belongs to f. Since f star be the image of f into E under the mapping psi, then psi is an isomorphism of f onto f star, and f star is a subfield of E isomorphic to f if we identify f and f star. If we identify A belongs to f with v plus alpha belongs to f star, then E can be regarded as an extension of f. Now we claim that E is finite extension of f. For this we shall prove that the n elements v plus 1, v plus x square and so on v plus x to the power n minus 1 from a basis of E over f. Therefore the degree of E over f is equal to n. Finally we shall show that Px has a root in E. Let Px is equal to a0 plus a1 x plus a2 x square plus so on an x to the power n, where a0 comma a1 and so on an belongs to f. If we replace a0 by v plus a0 comma a1 by v plus a1 and so on an by v plus an, then Px is equal to v plus a0 plus v plus a1 x plus so on v plus an x to the power n. We shall show that v plus x belongs to E, satisfy Px, and P v plus x is equal to v plus a0 plus v plus a1 v plus x dash plus so on v plus an v plus x to the x ka whole square whole n, which is equal to v plus a0 plus v plus a1 v plus x and so on v plus an v plus x to the power n is equal to v plus a0 plus v plus a1 x plus so on v plus an x to the power n v plus a2 v plus x ka whole square v plus x ka whole square is equal to v plus x and v plus x, or it can be written as v plus x square. Now v plus a0 plus a1 x plus so on an x to the power n. Therefore v plus fx v plus gx is equal to v plus fx plus zx. Here it is equal to v plus px, which is equal to v, since px belongs to v. Here the zero element of the field E, since the zero element of field fx by v is nothing but the coset v itself. Thus v plus x satisfy px. Therefore v plus x is root of px. The proof of theorem is now complete.